Okay guys, now we're going to make a quick diagram of an atom. So I would like to draw you helium and oxygen, just as examples. Helium, his symbol is capital H, lowercase e. Its atomic number is 2, and its atomic mass is 4. So that tells me, the atomic number tells me it has 2 protons, and the atomic mass tells me that if you take 4, subtract 2, it will also have 2 neutrons. So you will have 2 positive charges in your nucleus, and you will also have 2 neutral charges, neutral neutrons in your nucleus as well. And then spinning around the outside of that, you will have electrons. Now, you have different shells. The first shell is really close to the nucleus, and it will only hold 2 electrons. The second shell will hold 8. It maxes out. The third shell will hold more than that, but if we can, we consider it full at 8, and then we bounce them out to the farther out shell. But if you have chemistry, you'll learn more of those details. So because helium has 2 protons, it will also have 2 electrons, because in nature, charges want to stay balanced. So there's your example of a helium atom. And so I'm going to come over here and I'm going to draw oxygen. Oxygen will have, oops, let me erase, and I will write its stuff up here. So oxygen has an atomic number of 8 and an atomic mass of 16. So it will have 8 protons in the center, in the nucleus, and it will also have 8 neutrons. And then bounding around the outside, it will have 2 shells, and in the first shell, it will have 2 electrons. 8 minus 2 gives you 6. So in the second shell, you put the remainder there. 1, 2, 3, 4, 5, give them a buddy, 6. So it has 6 electrons in the outermost shell. And what's important about that is the outermost shell is what affects its bonding and how it bonds, how reactive or not reactive it is. Helium has a full outer shell, even though it only has 2, because the first shell fills with 2, so it's not going to be reactive. It's considered a noble gas. But oxygen over here is missing 2 electrons to fill up its outer shell, so it will either receive electrons to fill up to 8, or it will share electrons to also get to 8. Let's talk about compounds. Compounds are made up of 2 or more elements in a fixed position. You have types of compounds. Molecules are considered the smallest part of a compound that has the properties of the compound. 2 or more of the same or different atoms, however, can be in a compound. So you could have like O2 for oxygen, or you could have H2O for water, dihydrogen monoxide, or you could have NaCl, which is table salt sodium chloride. So you could have 2 or more of the same or of different atoms. So compounds are made up of different kinds of atoms bonded together. And a formula is a shorthand way of writing the name of a compound. And it tells us what is in the compound and the number of atoms present, or how many atoms are present. So the symbol tells you the atom, the name of it, and the subscript tells you the number of each atom that's there. There are 2 types of bonds that we're going to talk about really briefly. You have your ionic bonds, which is caused by the attraction of opposite charged particles. So electrons are transferred from one atom to another atom, and it will become, if you lose electrons, you become positive, because electrons are negative. So you have a positive atom, and then you have a negatively charged atom, and they are attracted to each other like magnets. And then you have covalent bonds, when this is where electrons are shared. So like you could share electrons to fill an outer shell. So O2, both oxygens are going to share 2 electrons so that their outer shells are full most of the time. So we have a couple of practice problems here. We'll look at the first one. CH4. The C represents carbon. The H represents hydrogen. Carbon does not have a subscript, so if there's any elements that don't have a written out subscript, it is understood that the number is 1. So in this CH4 you have 1 carbon, and hydrogen has a 4 subscript beside it, so you have 4 hydrogens. In this one you have H2O, so the 2 is beside the hydrogen to the right of it, so you have 2 hydrogens and you have 1 oxygen. Now over here it's a little bit different. NH2, CH2, COOH. I'm not going to try to say that one. There's the bell. So N stands for nitrogen. There's only 1 nitrogen here, so you could write it out. One moment,
Have your attention, please. One thing that I did forget to mention to everybody is you will be able to have a lunch break today at a normal human time. However, with that being said, that means we will have to stay today until 3:45. So I forgot to mention that to everybody. Thank you.
All right. So now it tells you that there's 5 of one of those atoms there. So you have to count up which atom has 5. Well, let's look at the next one. Hydrogen has 2 right here. It has 2 right here. And then it has 1 here. So 2, 2, and 2 makes 5. So this one would be hydrogen. Both of these have 2. So you can see that there's 2 carbons, even though they're not written together. And there's 2 oxygens. And the reason why they're written like that is if you take biochem and you look at it, you'll see that NH2 is a group that kind of groups together, and then CH2 is a group that groups together, and COOH is another group that groups together, and they act a little differently. So if I were to draw it, you would have nitrogen, hydrogen, hydrogen, bonded to carbon with a hydrogen here and a hydrogen here, bonded to C, double bonded to O, should be an oxygen there, it's not letting me draw, and then bonded to an O, bonded to an H. So that's what it looks like. It's actually the structure for an amino acid. NH2, CH2COOH is the building block for an amino acid, and this H right here will change, and you'll learn about that in next week's unit, but that'll change. It's called the R group, and it will determine how that amino acid acts. If you had me for AP biology last year, you'll know that that H is what affects how it bonds to other amino acids in its tertiary structure. So it is what caused the curl of the perm to work. And then this H and these OHs will come off and form water in a condensation reaction, and that's how that one of these will join to the next one. So then you would have another N. This would come off, the other hydrogen would come off, and you would have another N group, and it would build the amino acids that way. So that's how amino acids work, and that's why it's written out the way it is, so biochemists can understand what exactly is going on in the formula. So our next example has a parentheses, and it's just like in math. Anything outside the parentheses multiplies what is inside the parentheses. So you have a 2 outside, so it's saying that there are 2 NH4 groups in this molecule. So that means you have 2 nitrogens, and 2 times 4, you have 8 hydrogens. So I'm going to shorthand this. Nitrogen, you have 2. Hydrogen, you have 8. There's no subscript by sulfur. So for sulfur, you have 1. And for oxygen, you have 4. So I'm going to pause my video there, and I'll pick back up in the next section of notes.